Assalamu alaikum, everyone.
Sir,
Yes,
sir, I'm from group B1. Sir, I missed this class, so I joined here.
yes. Your ID
Sir, 77.
77.
Sir,
B2,
I am also from B1.
B1.
Yes, sir, I'm B1.
B1 এর হলো
Sir, ID
77 and
74.
74.
74.
Okay. From
Sir,
C2 97, isn't it?
Yes, sir.
Okay.
Yes, sir. Thank you, sir.
So,
Rubul, can you give me a minute?
yes.
Yes, those who are from B1, what is the reason behind for your you didn't join in the last class? What is the reason behind 77, 74? What is the reason?
Sir, there was
Sir,
load shedding in my area, and my phone did not have any charge.
Okay, and 74?
sir, I forgot about the rescheduling class, on the Thursday.
Okay. It's okay. Although, but try to participate in your own slot. Okay.
Yes,
Otherwise,
sir.
there will be in some period there will be overcloud, and in some classes there will be underclouded. Like I noticed that during the class with the B1, only 16 people are present. Okay, or are present 16 people. So actually, that was a very less number of people. Okay, so please try to participate in your own slot. Okay.
Yes, sir.
Okay. Rubul, please.
yes. Thank you. So, basically, in experiment 3, we'll discuss few things like shifting, scaling, and reversal of in time, and also Fourier series. And the theoretical part of shifting, scaling, and reversal, maybe that has been covered in your theory class, isn't it?
Yes, sir.
Yes. And also, one class has at least one or two classes has been already has already been taken by Dr. Rulamin sir on Fourier series, and at least you know one or two equations of Fourier series and the purpose of Fourier series, I hope. So if I subdivide today's lecture into few subgroups, then I can write here that we'll learn, first of all, we'll learn how to represent a signal. Let us say a equation is given and how to represent that signal in MATLAB. If you can remember at the beginning of our lab, we told that we'll learn in this lab how to represent a signal, how to operate on those signals, different theories that we'll be learning in signal system theory. We'll try to incorporate those theory in the lab. So basically, first thing you will learn, if a signals equation is given or a signal in let us say a signal is given, a picture of a signal is given, how to represent that in MATLAB. And after that, how to do some operations like shifting, scaling, and time reversal. That is the second thing. And third thing, we'll also will learn how to represent a periodic signal, because a non-periodic signal and periodic signal has a difference. Like there should be one, like after one period, the same thing will be repeat. The signal will repeat after every time period. So the number of cycles will be infinite in case of periodic signals. So the same signal will be repeating. So that is the we learn how to represent those type of signals. That one cycle is given, the attributes of one cycle is given, how to represent the other cycles. So the last thing that we will see about the Fourier series. So let's see. Let's start with the representation of a signal. So okay. So before going to there, because just after the time shifting, scaling, and all those things will become coming up. So let me ask. Okay. 91. Kais, are you there? Kais. 91.
Yes, sir.
Yes. So keep yourself unmuted. So you already know about time shifting, isn't it?
Yes,
Guys?
sir.
Yes. If xt is our original signal, so and t0 is a constant, so xt plus t0, the signal will move to right or left? What do you think?
Sir, To the left.
And t minus t0?
To the right.
To the right. So I think these things are clear. Okay, tell me about time scaling. So the multiplication factor, let us say a. So if a is greater than 1, what will happen? xt is your original signal and xat. So a is greater than 1.
Yes, sir. The signal will be compressed.
And a less than 1?
It will expand.
It will expand. Okay. Then the things are given here. I am just confirming that you have already learned this thing before me. So xt is your original signal. So if I do time reversal x minus a, it will be going to the negative side, isn't it? Guys?
Yes, sir.
And then it will be mirrored along the y-axis because
Yes,
t is your x. Here is your x-axis. So if we are doing x minus a, that will be reversed. Okay. So so these are the theories that will be needed to do the operations. Now we have three signals that we have two signals basically that we will try to represent. That any signal, if you have the equation, then you can represent those things in MATLAB, and also you can do the operations. So first thing that we will do, we will try to implement exponentially damped sinusoid. So exponentially damped sinusoid is xt. So it is e to the power minus t and cos twice pi t. So we will represent this particular signal in MATLAB, and after that we will define unit step function. Okay, guys, can you tell me what is unit step function? How should it look like? Guys, can you hear me?
Yes, sir.
Yes, sir.
Yes. Have you heard the name unit step function?
Yes, sir.
Okay, then what is the attribute of that one? So can you tell me, can you define unit step function?
Sir, it will be like a constant straight line.
So for all the time, or there are some restrictions on time?
No, sir. There are some restrictions, definitely.
You cannot remember, isn't it?
Sir.
Okay, who was trying to answer?
Sir, the time needs to be greater than 0.
Yes, from 0, basically from 0,
Yes,
that
sir.
means at 0 it will switch to 1. So for any time greater than 0,
It will have a value 1.
It will be
Yes,
1. So now you have heard about the inline function, isn't it? Okay, let me go to 92. Sakib, are you there, Sakib?
Yes, sir.
So have you heard about inline function?
Yes, sir.
So what we do normally using inline function?
Sir, to declare a function.
To declare a function. So what have we done here? Can you see the equation?
Yes, sir.
So basically, this is the same equation that we were trying to declare, the exponential minus t and cos twice pi t. So basically, inline function, and you can see it will be removed in future release of MATLAB. So they are recommending the anonymous function. So basically, you can see this is the same function that we are trying to display. So here the syntax is with the inverted comma, there should be the function, and then after comma, then inverted comma, here there will be your variable. After that, whenever we will be calling that function, we should supply that particular variable t. So here we are plot t comma xt, that means t is x-axis, xt is your y-axis, then we can plot the same thing. If I just run this function, then you can get this one. Is it clear? Yes. Now the same thing we can do using anonymous function. So what I'm trying to show you here is that it is very simple thing that how to represent the equation and how to see the plot. So it is a very easy thing. But what is the thing that you can look at here? You can actually do the same thing using anonymous function. So here the syntax, after this sign, you should declare the variable, and then you need to write the equation. So same thing, whenever you'll be calling that particular function, you need to supply the variable, isn't it?
Yes, sir.
Okay. Now 92. I'm just asking one thing. So can you see this syntax? Dot. Then after that you have a multiplication sign or asterisk sign.
Yes, sir.
So what does this implies? What does this imply?
Sir, element multiplication, sir.
Element-wise multiplication. So why we are using this element-wise multiplication?
Sir. Sorry, sir.
Okay. Can you tell me what does this means? Exponentially damped sinusoid. That means there will be a sinusoid which will be yes.
Which magnitude will be decreasing.
Yeah, magnitude will be decreasing.
Exponential decay.
Yeah, is exponential decay. So when we will be multiplying that these two, exponential minus t and cos twice pi t, so it will be decaying exponentially. But thing is that here the variable is t. Let us say you have 100 values. This is a vector. It's 100 values of this row vector, and also there will be hundreds values of this cos twice pi t. So if we want to get x for that particular t, so we need to do this element-wise multiplication. So here matrix multiplication will not work. Is it clear?
Yes, sir. Yes, sir.
So although it is easy, but just you just try to get the things. So again, I have shown here another way to represent. Okay, you can declare the variable t first, and after that you can calculate x, exponential minus t. But here the problem is you are not doing this as a function. So whenever you will try to operate this on time scaling or a reversal, or if you want to do shifting, then you cannot use this particular one because you cannot supply xt or something like that. But here if you directly write twice t, or if you write 0.5 into t inside this function, then what will happen? That will directly work as scaling. So maybe after one or two courses, we'll see how this has been scaled in different scale. How can we do the scaling using these functions?
Yes, sir.
Now, what's 138 was saying that okay, that step function is something like that. It will be 1 from 0 to the values upper than 0. So we can do that thing using inline function also, and also using anonymous function. Now 92.
Yes,
so here I have the variable t, isn't it? T. We have one variable from -5 to 5 with the increment of 0.01. Can you see that?
Yes, sir.
Yes. Now how does this simple thing implies that it is a unit step function? Can you tell me?
Sir, sir, we are doesn't giving a value, so there will be 1, the magnitude, and the magnitude is 1 after t equal to 0. So we are getting 1 after t equal to 0. So that's why it is unit function.
Yes, basically thing is that this is a logical function, isn't it? Like for every t, every value of t, let us start from -5, -4, -2, -1. So will it be true or false? So it is a logical. It will give either 0 or 1.
Yes,
are you
sir.
getting me?
Yes, sir. Yes, sir.
So for -5, -4, -2, -3, what will be the value for this particular
0.
case? It will
False.
be 0. But whenever it will be 0, so it will be, the value should be 1, isn't it?
1. Yes, sir.
And for the values greater than 0, it will give 1. So just these two. There can be other ways to represent unit step functions, but this is a simpler way to just giving a logical function that okay, I have t variable And I'm just using the logic that, okay, this t is greater than equal to 0. That means whenever it will be less than 0, it will give 0, and whenever it will be equal or greater than 0, it will give 1. So if we just run this section, then I can do this. Now, the another thing, that ut minus 1. So what do you expect from here? So try to see, we are changing the way that we have learned in theory. So ut minus 1. So what do you expect, guys? This unit step function ut, and we are trying to do shifting operation. So what does this t minus 1 will do?
So shift to the left 1.
Shift to the left, and then this one
Shift to the right.
Okay, and this one?
So it will mirror the
Okay.
value.
So if this is our original one, so let me run this section.
No, sir. I think he said the opposite.
Yes, that's what I am trying to show him.
Oh, sorry, sir. Oh, yes.
For t minus 1, it should be
Right.
right, yes, and t plus 1, it will shift it to the left. And actually thing is that these things are similar. So if you can represent a signal, then you can do the operations easily. So basically this ut can be any function, not only unit step function. It can be any function that you have declared using inline or anonymous function, that then you can actually do the shifting, scaling, reversal thing. So the last portion for the scaling. Okay, so now in this case, guys, so xt is our original signal, let us say, the exponentially damped signal, and then what should be x twice t?
Sir, it will be 2 times compressed.
Compressed, yes, and then 0.5 into t by 2.
2 times expanded.
So if I just run this section, you can see I'm telling you the same thing. The equations that you have seen in signal system, if you can represent any signal using anonymous or inline function, then you can do these operations there. Is it clear? So here you can see if this is your original signal, it has been compressed and it has been expanded. Is there any question up to this or anything that you want to ask?
No, sir, clear. Now, before going to Fourier series, you know that Fourier series is connected with the periodic signal. So let us first learn that how to represent a periodic signal first. Okay, let me go here. 3.3.2. Now, let me go to the 97. Are you there?
Yes, sir.
Yes. So keep yourself unmuted, okay?
Yes, sir.
Now, let us say it has been said that it is a periodic signal. Okay. So can you tell me what is the time period of this signal, xt?
Sir, 1.
1. So thing is that there can be many ways that we can we can have this problem. Like it may happen that this only signal is given to you. Now you need to do the to represent this signal using MATLAB and then doing different operations, and also you can use this to represent the number of cycles that you want. And also it may happen that the equation things are given for this. Now 97, can you tell me that can you tell me that how to represent this? Let us say only this thing with the coordinates are given. So how to represent this thing in MATLAB? Like, what do you think? Any case? There's any signal, not only this one. Any signal is given. Now we need to represent that periodic signal in MATLAB. So how to do that thing?
Sir.
Yes. Sorry. So 97, should I move to others?
Okay, sir.
Yes, yes. Is there any other? 88.
Sir, we can use sawtooth function.
Yes, you can use sawtooth. Any other? Yes, 15.
So we can use a piecewise function.
Yes, yes. So I'll take both the answers, but thing is that whenever you will be having triangular wave, you can use sawtooth, and you can do operations like shifting, and also in x-axis also you can shift using adding 1 or 2 or something like that. But thing is that when it can be any function, so you need to go for the piecewise equation. Okay. So here we can see the equations are given. Like there can be, if I say from 0 to 1, there is one complete period. So from 0 to 0.25 we have one straight line. From 0.25 to 0.75 there is another straight line, and from 0.75 to 1 there is another straight line, isn't it?
Yes, sir.
Yes, sir.
So basically you can do this for periodic signals, for other periodic signals also. So now you have the coordinate here 0, 0, and you have the coordinate here as 0.25, 1. So 97, are you there?
Yes, sir.
So if we have these two coordinates, can we find out the equation of this straight line?
Yes, sir.
Yes. So also if we have the coordinates, then we can do here, we can do here, isn't it?
Yes, sir.
So here basically 3 parts has been taken from 0 to 0.25. It is 40. Then 0.25 to 7.75. It is this equation, and the equation for 3 straight line with their limits from 0 to 1 has been given. 3 separate equations. Now if we have the equation, then now it is easy to represent this particular function or any periodic function or any periodic signal in MATLAB. So now before going to the code, I want to discuss a bit more about this thing. Okay, 97, you can keep responding. Okay.
Yes, sir.
Okay. So we have this particular equation. Let us take 2 cycles of this. So let us say it is 1, this is 0.5, and this is 0, isn't it?
Yes, sir.
And here you have 1. It is your xt, and this is your t. So if the equation of this particular straight line is 4t, isn't it?
Yes.
So what will be the value? Okay, no. So it is basically 0.25. So what will be the value at t is equal to 0.2?
0.8.
0.8, isn't it?
Yes, sir.
Now let us say it is here at 0.2. Now what will be the value at 1.2? What do you think? Like if it is a periodic signal, yes? 97.
0.
Note 1.2. It is here 1.2. Okay. So if we go for t is equal to 1.2, so from equation it is coming 4.8, isn't it?
Yes, sir.
But what do you expect that what should be the value at 1.2 if your time period is 1?
So it should be greater than 0.
Yes, obviously.
But not that much value.
No, I'm asking the value that you are getting at 0.2. Should it be same or different at 1.2?
No, sir, it should be same.
It should be same, isn't it?
0.2
So if it is
and,
0.8 at 0.2, so at 1.2 it should be 0.8, isn't it?
0.8, yes, sir.
Yes. At 2.2, what should be the value? What should be the value?
0.8 as
0.8.
well.
But if you calculate, you'll get a different value. So we want that all these values should be 0.8, isn't it?
Yes, sir.
So how can we do that thing? Because at 1.2, if we use the same equation, then we'll be getting 4.8, which will be much higher than this value. So we need a mechanism by which we can transform these values into 0.8. Are you getting me?
Yes, sir.
So there we can use actually the mod function. So have you heard the term mod?
Yes, sir, I have heard.
So if we have mod xy, what will be the result? Let us say z. Anyone?
Sir, we basically get the remainder.
Remainder 88.
Yes, sir, when we divide x by y.
Yes, we'll get the remainder. So here what we can do, let us say we have t. The t variable is from 0 to, with the increment point 0.01, let us say up to 5. That means we have this number of total time. Now oh, let us say it is 0.2. So if we use mod t comma 1, so what will happen? So
t divided by 1.
Yes, let us say we are taking 0.2 comma 1. What will be the result?
Sir,
so 97. Okay, let me go to 97. Have you understood what is the function of mod?
Yes, sir.
What does mod do? Huh?
Yes, sir. 0.2 divide 1, it will give the remainder.
Yes. So it should be x will be divided by y. Okay.
Yes, sir.
X will be divided by y. So here it is x and this is y. So now tell me what will be the value for 0.2 comma 1 and then 1.2 comma 1.
0.2 first one.
Yes, and then second one.
The 0.2.
0.2. So same thing if we use 2.2.
Yes, sir.
0.2, isn't it? So the same thing that we are asking here, that all these values should be within the range from 0 to 1. So sorry, not that one. Like I was saying that if all these values are transferred to 0.2, then we can have the 0.8 for all the cases because the equation is 40, isn't it? So what I'm trying to say, if we use mod t comma time period t, in this case this t is 1. So if we use this particular function in place of t, then that can solve our thing in case of periodic signal. Is it clear to you?
Yes, sir.
Is it clear to you?
Yes, sir.
So whenever, so in place of 40, now we can use 4 into mod t comma t. Are you getting me?
Yes, sir.
Okay. So other than 97, do you have any problem during understanding this particular part? Anyone?
Sir, can you repeat the question?
Yes, I'm just asking that whether you have understood or not. Do you have any confusion up to this? 15?
Yes, sir.
Buchko.
Yes, sir.
I think things are
Sir, small t is the array and capital
yes,
T
small
is the
t is your time axis values, and capital T is your time period. So if your time period is 2, that means this 0.2 should be equivalent to 2.2, 3.2, isn't it? Sorry, 4.2, because your capital T is 2. Are you getting me?
Yes, sir. Yes, sir.
So after every time period, you should get the repeated version of the first from 0 to that particular time. Is it clear?
Yes, sir.
Okay. Now I'm just giving you 2 minutes to just see the code and try to understand what is happening here. Okay.
Yes, sir.
Okay. Okay, is there anyone who can just explain a bit?
Yes, sir.
Yes, yes.
Yes.
Sir, we are defining the piecewise function with the conditions of the time, like from 0 to 0.25. We are using logical operators to do that.
Okay, that is the same thing that it was 88 was saying, that we have used mod t comma 1 in place of t, and then you can see 4t, then a element-wise multiplication with the condition. So 2 minus 4t, then the condition. So what what is the thing that you can see here? Okay, it has been done with anonymous function, so you can use this one. But 88, can you tell me
Yes, sir.
why have we used that plus sign? Like those will be added together, or what will happen? Like what is the
Yes,
use
sir.
of that
They will be
positive sign?
added together, because
So-
like if one condition is satisfied, the other conditions won't be satisfied.
Yes. So at a time, only one will be satisfied. Only one condition will be satisfied. Only that value. So from 0 to 0.25, only that one will be satisfied, and after that, from 0.25 to 0.75, those will be satisfied. Very easy thing. So basically, 2 will be 0 and 1 will have the value, and that will be either of these. Now try to get, we are transferring the whole t variable using mod t comma 1. We are taking the taking this particular t value within this range from 0 to 1, so that we can calculate xt using those values from 0 to 1. But whenever we will be plotting, so we'll be plotting with t. So as many as cycles that you want, you can change the t variable here, and then you can get the output here. So you just run this function. It will give you 3 cycles of this particular signal. Is it clear? Is it
Yes,
clear
sir.
to all? Yes. So now we'll see few things regarding Fourier series. Now, first of all, let me ask you, what do you know about Fourier series? Like whenever someone is asking what is Fourier series and what is the purpose of using that Fourier series, so what is the first thing that comes to your mind? So sorry. So let me go to 98. Are you there? 98.
Yes, sir.
Yes. So can you tell me about Fourier series? Like what do you know about Fourier series?
Sir, we use Fourier series to model any periodic signal with a combination of sine and cosine.
Yes, that means you can rephrase that thing using, okay, we can represent the periodic signals using the weighted sum of the sinusoids, isn't it? Or weighted sum of the exponentials.
Yes, sir.
So that is the thing. Okay, let me write the equation. So basically this is your, I hope that you have seen this particular equation, isn't it?
Yes, sir.
Yes.
So using this particular, your any periodic signal xt can be represented with weighted sum of sinusoids. So sinusoids can be translated to exponentials, and this is your weight. So today what we will learn, so if this xk is given, if your xk is given, so using this equation we'll reconstruct this xt. Okay. So here one equation, actually this is this is one of the representations of your Fourier series, you can say. So and maybe in second year you have seen this particular equation, isn't it?
Yes, sir.
Maybe in second year. So in terms of cosine and sine. So if we just rewrite the cos and sine in terms of exponential, finally you will get this particular equation. So which can this can also be translated to this equation. So there are ways you can go find out that one. But thing is that today we will see that we'll use this particular equation. That means this equation to reconstruct, and here CK that you are seeing, that CK, and so BK and AK, those are you can say sinusoidal coefficient, Fourier coefficient, and CK you can call it as exponential Fourier coefficient. So CK and XK that has been used here, XK in your equation, your familiar equation that you have learned in your theory class. This XK and CK for our lab, these two are same thing. So this CK will be given to us, and we'll try to represent and we'll reconstruct the XT and try to match the XT and original XT by visualization, obviously. Another thing is that there is a variable K by which you can increase the terms. That means how many exponential or how many sinusoids will be added to represent or to reconstruct the original signal XT. Is it clear? So you can vary. So in the equation it is from 1 to infinite, but we cannot define infinite, isn't it? So we need to give a number to that infinite. So that is given here, n. So we can vary from 1 to a particular number, up to which we can see that this has been reconstructed. So you can see here, so for k is equal to 1, so this black one is your original signal and the blue one is your reconstructed one. So using k is equal to 1, it is just a sinusoid. Then k5, then you can get this one. Then if we increase up to k49, you can see it is almost the same as the original signal. Is it clear?
Yes, sir.
Yes, sir.
Now here one thing is that you can hear the condition. You can hear about the conditions of having Fourier series for a periodic signal, because all the periodic signals actually does not have Fourier series. There are a very few conditions, just a simple conditions are there. So one of the conditions suggests that if any periodic signal has finite number of discontinuities, then it can be represented using Fourier series coefficient, like Fourier series. There can be that can have Fourier series expansion. I'm repeating. The condition suggests that one of the conditions suggests that if a periodic signal has a finite number of discontinuity, so it can have the Fourier series expansion. So Fourier series expansion means there will be Fourier series coefficient, and also using that we can reconstruct the original signal. But that is theoretical thing. But practically what happens, it cannot be exact, because your exponential and sinusoid, those are continuous time signal. But using all the continuous time signal, you cannot create a finite number of discontinuity even. So what happens, you can see here. So even if you increase the number of terms, there are some glitch at those discontinuity. So why I'm telling this as discontinuity? So I'm asking just 81 as you are responding. So at this particular point, what is the value of your function xt, let us say? This particular function. Yes?
Undefined, sir.
Undefined. That means basically it is a transition from 1 to -1. So it is not possible. This is the discontinuity. At a particular time, it cannot be 1 or -1. It is not possible. So basically, at this point, at this discontinuity, sorry. So at this discontinuity, you can see there are some glitch. So even if you increase this number, it will be almost similar or almost same, but it cannot be exact. So this phenomenon is called the Gibbs phenomenon. So for lower number of k, you'll find more of that, but for higher number of k, for higher terms, you'll get only at the corners. Is it clear to you?
Yes, sir.
Okay, I hope so. So let me go to the demonstration part. Now we have one function xt that is periodic. It has been given. So now in this case, you can see the equations are given, not the figure, or not the okay, obviously the figure. So here the equations are given. So what is the time period for this one? Why I'm telling about time period? Because whenever you're going to calculate this particular omega 0, what is omega 0? I was going to 98. Are you there? 98.
Yes.
Okay, keep yourself unmuted.
Yes, sir.
So can you tell me how can we find omega 0? Do you know the formula?
No, sir, I don't know.
Okay, 34. Do you want to answer? 34.
Yes, sir.
Yes. What is omega 0?
Sir, omega 0 here is actually 2 pi by t, and it is a fundamental frequency.
Yes, 2 pi by t. 2 pi by t. So every time whenever you want to, all the equations have that omega 0. So you need to know this t. That's why I'm asking that what is the 34, you can answer. What is the time period for this particular function? Or 98. You can try. কত এটা টাইম পিরিয়ড কত
স্যার অ্যানসার করব স্যার?
হ্যাঁ কত বলো
স্যার 1/2.
1/2.
Yes sir.
Okay.
Oh no sir. Wait. 5/2. So 1/2 তো হওয়ার কথা।
98.
Yes sir, 1/2.
1/2. There are two separate pieces of this equation. That means I have told you that you can subdivide those periodic signal into few pieces, and then after that you can find out the equations for those, isn't it? So now you can see it has been started from -0.25 to 0.75. So in time, how much is that? From -0.25 to 0.75?
0.5.
Huh?
0.5.
So are you adding, or there is try to get it. Okay, let me go to another one. Can answer korbo arekjon bolo?
So 1.
1, yes, because it is in time domain. So you are at 0.25 minus 0.25, then we have 0, then 0.5, and then you have 0.75. So how much is that? This 34. Are you getting this?
Yes sir, this is 1.
Yes, that is the same thing given there. So there is a complete function have two separate pieces. So previously you can see here you have 3 straight lines in this particular function, but you have two straight line.
Yes sir, yes.
Are you getting now?
Yes sir, I understand now.
Okay. Now we have this xt and ck, that means your xk is given here. So this is your xk. So after that we will reconstruct the xt using this ck or xk, whatever you say, and we'll use this equation to reconstruct. Is it okay?
Yes sir.
Yes. Okay, now okay, I'm just giving you 3 minutes. I think 3 minutes will be more than enough to try to see this code and try to get what is happening here. Okay. Okay. Is there anyone who wants to explain this one a bit?
Yes, sir, I can try.
Yes, 34.
Sir, first, as we defined earlier, sir, we have to identify the time period. So
Yes.
since we from the equation we can see that the time period here is 1 unit, sir, or 1 second as we say. So now we can see that we have taken two ranges. One is t1 and one is t2. That equates the ranges of the two functions, which is 40 and 2 minus 40. After that, sir, we take the value of x1 and x2, which is given as the function in the equation tab. And then, sir, furthermore, we take x as x1 comma x2 and t as t1 comma t2, which equates as the functions and the values of the time, which is given in the equation, in the main equations given in the picture. After that, we take the plot command. In x-axis, we take the value of the time, and in the y-axis, the value of the given function, which is as x1 and x2, given which we have previously selected as x and t.
Yes.
Followingly, we have taken another command, which is zeros n and n comma length t, which will be a value of zeros, an array of zeros, which will be in the dimensions of n and the length of the total time. And now from the next statement, we have taken a loop, which will be from 1 to the ending value of the n. So, and in this loop, we will take two different commands, which is d, and this d equals to the value of the function, which is defined here, which is minus 4j the ck. Yes, sir. And since we there's a thing called minus 4 into L1i, since this I is the complex number, which is indicated in 1 into I, and in the next line,
Yes, yes.
we take,
Just next line is the equation, isn't it?
yes, sir, excellent.
Yes. After that, what is the function of this cumulative? This is.
Okay, this is
Can
the
you explain after
cumulative-
that?
Yes,
Yes.
sir, this is the cumulative sum, which will take the sum of the column wise. Every column wise it will increase the sum as the previous value
Yes.
cumulatively.
So, what are we plotting here, basically?
So we are plotting the cumulative sum, the column wise value. So
Yes, yes. But what does this k implies? Like, what does this k
Sir,
imply?
sir,
What is the
sir,
value
this-
of k in this particular case? Let's say your n is 2. So, what is the value of k here?
So the k will be, sir, 0, 1, and 2.
No, no, no. But during the plot, this k value is fixed. We're not changing it, isn't it?
Yes, sir, that's true. We're not changing it.
Yes, but so after running the whole code, what will be the value in this particular line, the value of k? So here, one thing you need to understand. Okay, let me. Okay, thank you, 34. So try to understand. This first part is basically we're trying to represent this signal from the equations, not xk. This is xt. The equations are given, but here manually we have plotted only one cycle. But if you want to plot a number of cycles, then we need to go for the trick that we have learned about the mod function. So that has been given as your task. Here you can see the plot the periodic signal xt of 3.3.3. Basically, I'm referring to this one. You need to plot for a number of cycles using a mod command. Okay. So that is our first part. The second part, okay, the zeros, the number of rows will be number of n, and number of column will be number of t's. And then after doing the calculation, after doing the cumulative sum, basically the last line should have the summation of all the previous rows. The last row should have the cumulative sum, or the sum of all the rows before that one, including that, isn't it? Are you getting me?
So shouldn't it be columns, sir?
Yeah, addition is column wise, but you will get the results in a single row, isn't it? Yeah. That's what I'm saying. Okay, let me. So here we can see just one example: 1, 4, 7, 3, 9, 15, 6, 15, 24. Okay, sorry, this is the result. Basically, this is your 1, 2, 3, 4, 5, 6, 7, 8, 9. Now here we can see 1, 4, 7 has been added with 1 plus 2 is 3, then 4, 5, 9, then 7, 8, 15. Then this 3 plus 2, this 3 plus this 3 is 6. Then this 6 with this 9 is 15. This 15 with this 8 is 24. That means your last row is having this column-wise summation. That means all sum of all the previous rows. Are you getting it?
Yes, sir.
Yes. So these are the values that you are adding. So you just try to correlate here. We have the summation sign. So we want to add those things in columns by using the cumulative sum. Now this k, after running this whole for loop, this k value will be equal to n, isn't it? That means it will be indicating to the last row.
Yes.
This k is indicating to the last row and all the columns. So basically, for this, whenever you will be using n is equal to 2, that means you will be getting a similar, but you can see it is obviously distorted. But if you by the time if you increase the number of what should I say? Okay, you have to run here this one first, and if you increase number of terms to 5, then you can see from 2 to 5 it will be more similar to the original one, and if you increase to 50, then it will be almost similar to the original one. Now during the reconstruction, you can see we are getting only one cycle of this particular signal. But if you want more cycles, then you just change the time axis values. From if you make it from -1 to 2. Now if you run this particular section, all the things are as before. So you'll see there will be three cycles from, you can see, from 0.25 to 0.75. This is one cycle, this is another cycle, and you have another part cycle. So that is the thing. Now we can do the same thing for any xk. So if we have if you have been given xk, then you just need to put it here, isn't it? 34. If we have xk for any periodic function, then you need to change this thing only, isn't it? If you want to reconstruct.
Yes, sir.
So other things will be same. So that is the thing. So for any xk that has been given, that will be given to you, or that can be given to you, so you can now reconstruct the original signal using this particular thing. Now that is actually today, that is the I think that is the end. But another thing that I wanted to tell you is that using this plot periodic signal of xt, so here I want to mention one thing, that whenever you will be using mod for a negative number, like here you have -0.25, then you may have some you may have some issue. So as your mod function is nothing but following a particular equation, so just I am giving one hint that you can I just want a number of cycles of this xt. So you can shift, you can scale, you can shift in amplitude by any means. I want just finally I want few cycles of this particular signal. Is it okay?
Yes, sir.
You're getting me? Yes. And another task that I wanted to add here, so just you can write in your notebook or you can write anywhere, that here you need to rewrite this code by changing only this particular line with this equation, the equation that you are familiar with. So try to do with this equation and try to see whether the results are same or not, and try to keep in your mind that for k is equal to 0 we had some separate value. So in this case, let us say for k is equal to 0, xk is 0. So for other values, try to get try to use this equation for the same function that has been given in 3.3.3. Is it okay?
Yes, sir.
Okay, now that's all basically. So if you have any question, you can ask. And let me, I have already taken, basically I have noted down the IDs who are present, but a few IDs are missing. Let me announce those. Okay, Niloy 16/147, maybe he is not present. Okay, 93, Sadman Abid.
Sir,
Oh, sorry, that is from B2, isn't it? You're from B2. So is this year 93?
sir, আবিদের মনে হয় নেট কানেকশন নাই।
ওকে, ওকে ফোন দিতে বলো আর কি, ও যদি অন্য কোথাও কারোর সাথে পারে করবে। ওকে, দেন 99, আশিকুর রহমান 99 is absent. Then 179,
Sir,
93.
Sir,
Then
99, he's in his village, sir. So he has very low network coverage.
99. Okay.
Yes.
Okay, but he missed other labs also. Okay. Okay, let him contact me. Okay.
Okay.
So other than this, all are present, and also I have noted C2 97 and from B1 77 and 74. Is it okay?
Yes, sir.
Okay, that's all from my side.
Sir, for the 4616 assembly lab, is it possible to extend the deadline like 2 or 3 days?
Yes, there's actually, I should say there is a mistake from my side that I have not uploaded those things.
Yes, sir.
Let me talk to Arif, and maybe we can extend, you can submit 6 and 7 together in the next week. Will that be okay?
Yes, sir, no problem with that.
Okay, let me talk to him first. Okay.
Okay, sir.
Thank you.
Okay, sir.
Assalamu alaikum.
Assalamu alaikum.
Assalamu alaikum.